Hey there, my name's Chris Solarski and I'll be talking to you today about 3D modeling basics. I will be using a program called Blender to demonstrate some of the principles, but they are very general, applicable to all 3D modeling programs. And to begin with, I just want to mention that this video does have an accompanying slide presentation, which is displayed here at the moment, and I'll be continually referring to this, and it'll be available as a link in the description of the video. So just to get going, every or most 3D modeling programs have a native file format. So this is the basic thing that happens when you press File, Save. In the case of Blender, you have .blend as the file extension. And of course, a program like a 3ds Max has .max as the extension, Maya.ma or .mb. But there are sort of file exchange formats. This is referring to this section here, which are used by programs like X3D DOM. X3DOM. And what they allow you to do is to transfer information between these sort of standard 3D modeling packages. And there are some additional considerations when using file exchange formats, which I'll cover shortly. In general, every 3D program, of course, exists in a 3D space, which by if you think about it, it is an infinite space. There is no reference point by default. So every 3D program starts or has at its center an origin point. So the origin point is at 0, 0, 0. And this is illustrated by this grid, which you can see me rotating now, and this box in the middle, which is positioned right at the origin point, is also located at 0, 0, 0. So you can see this in the right hand here, so 0, 0, 0. There are, however, so there's a system that we can use to move this object. So this is a coordinate system, and it has both negative and positive movement. And movement is along three axis points. This is defined by the z-axis. In Blender, it's z is up and down, x is left and right, and y is forward and back. So if I go into this program here in Blender and I click to grab the object in the z-axis, you can see in the right hand the z-axis is generating positive values as I move further up. But as I move below the origin point, you can see that minus values appear. So I'm going into negative z coordinates. Same thing happens if I choose grab and y, so move the object back and forward within the coordinate space of Blender. And you can see moving it to the left creates a negative value, and moving it back creates a positive value. But as you can see, the coordinate system makes it sometimes a little difficult to understand what is left and right, what is forward and back, and that's because, of course, the scene can be rotated all the time. And what allows you to sort of keep check of where you are is usually this kind of gadget widget, which rotates together with the screen, so you can see it's rotating around and constantly reminds me of whether X is left and right or Y is forward and back, and also using the color coding as well, which is a standardized color system used across the 3D modeling packages. This is also important to remember for when exporting files, and this is why I mentioned the exchange file formats, because if you are exporting using something like X3D or FBX or OBJ, these are very conventional file exchange formats that allow you to maybe use a 3D model from Blender, for instance, in Unity game engine. What is important to understand is that some of these coordinate systems may differ. So if I go back to this slide, you can see that Blender has Z as up and down, but Maya has Y as up and down, as does Unity. So when exporting your files, it's important to understand, what the target coordinate system is, because you might find that your models are imported upside down or back to front, if you haven't set the translation correctly. So this is just a preview of what happens in Blender when you press select FBX as an export. This is different to saving something. Of course, exporting is when you want to transfer it to another program, and then it gives you the options to select what is forward and what is up. The next thing is the object editing basics. So we have here a cube. This is an object. You can think of it as a form, a basic form. And if I click Shift A in Blender, I get these primitive forms. So I can generate a plane, a cube, a circle, spheres, cylinders, cones, and so on. And these are often referred to as primitives. You'll find them in every single 3D program. They're referred to the Platonic solids invented by the ancient Greeks. A little bit of background information there. But they are objects in themselves, but there's something that's, irrespective of their form, they have something that is consistent between all of them. And if I make this object transparent, we can better see what they consist of. And the basic components of every object are vertices. So these are the points in between the edges. The edges themselves, so I can move these independently too, or the surfaces themselves. So I can move this, and by doing so, if I grab a face, of course it does of course mean by default that I'm also grabbing the edges and the vertices to which that face is connected, or is sort of created from. So this you'll find is how you start to edit objects in a 3D program by moving these objects around, sometimes scaling them together. So if I sort of grab these like this and scale in the X, you can see I can start to make a more complex form based on the original box form. So this is somewhat explained using this slide, and just to remember that every object consists of edges, faces, and vertices. So if we move down the presentation here, what I wanted to also highlight is that object editing, of course, is at its most simplest done by manipulating these edges and these vertices and these planes. But you can also use sort of tools like the loop cut, the knife tool, and bevels to add another level of complexity and maybe add more edges and vertices to your form. So if I find that I need to um, sort of expand and scale this cube down the middle, I can use a loop cut tool, and then it creates another set of vertices and edges down the middle, and then I can scale those to create yet more complex forms just like this. And these are the shortcuts exclusively for Blender, but the tools themselves are very general, and you should find them in all 3D programs. Another very important tool to use are sort of modifiers, especially the Boolean tool. And you can see here that the Boolean tool has been used to combine a sphere together with a box to create much more complicated forms than are often possible to model just by using grabbing and scaling and rotating the vertices um, and the edges and the planes. So Boolean tool is also worth looking up in whichever program you're using, because then it can, by combining several forms together, you can very quickly create more complex forms. And before I continue, it's also worth noting that, of course, as well as moving these points around, I can also rotate the forms as well. So if I rotate in the Y, so you can see the form is rotated like this. In every 3D program, this can be done within the viewports. This means this kind of virtual space that you see before you, or by adding numerical values in a matrix like this. And the same thing happens for scaling. I can scale within the viewport, as well as scale within a particular axis or several axes at the same time by adding, inputting numerical values on the right. So moving on, every 3D program, of course, will give you the option to add light. So in this scene, we have, as well as a camera, a light here. So to actually see what it's doing, I just click on here, and you can see that now the object, which is quite flat, lit with ambient light, now actually has shadow surfaces depending on the position of the light. So the light itself can also be moved. So if I move it around here, you can see how the object itself starts to be shaded differently based on the position of the light source. And what can be done there in addition to that is changing the light to sunlight, which of course just simulates light rays coming from one particular direction parallel to each other, a spotlight, and which you would find in a like on a theater stage. So just I can add a plane just to give you an impression of what that actually looks like. So something like this. And just move that into position like this. And an area light, which gives you the option to create a light of a particular shape to it. What is also worth looking out for is ambient occlusion when it comes to shadows, because of course adding a light generates shadows, but adding a somewhat more realistic shadow effect is created by ambient occlusion, where it creates shadows where objects come together. So this is sometimes referred to as contact shatten or contact shadows, as you can see here. So on the left is without ambient occlusion, where you just have the form light and shadow, whereas on the right you can see that there's shadow in between the objects which are very close together. Also worth noting is that light can have a color value, so we can change the color. So by default, of course, light is going to be white and the shadow is black, but you can create a much more realistic effect by adding things like an orange light, which simulates sunlight, and blue shadows, which is sometimes done by changing the environment color to blue. And so you can go like here from a very black and white gray scene on the left to something which is much more elegant and also has some ambient occlusion in the shadow. You can see it gets slightly darker nearer to the form, around the form edges where it touches the plane below it. Also to consider are texturing. So of course, forms, we can change the color of forms, sort of often in a program like Blender. It's the idea of applying a material and then a base color, as you can see here. But you can also replace the base color with an image, and this is exactly what is done here, where as a rock texture has been applied to the object. And what this creates is a UV map. You can see a UV map here on the left. And what a UV map is, in essence, is the object unwrapped. And this is a great illustration on the right from conceptartempire.com, where you can see a 3D form has been almost like a banana, sort of unwrapped and flattened. And this is exactly what we're looking at when we see this UV editor mode on the left, illustrating how the texture is, or in which position the texture is applied to the cube on the right. And so these UVs and these points that are illustrated on the left can be edited in very complex ways. And you can see here, depending on if it's the characters, can be really made up, the materials can be made up of several images. But you can see how complex the UV editing can be, where you have to unwrap this complex mesh and try to flatten it down to a 2D image before you can start painting it using hand painted techniques in Photoshop, for instance, or even photographic textures. And then finally, I mean, there are lots of different ways of texturing an image, from simple painting to adding normal maps and specularity. But that's it for now. That's the 3D modeling basics. And please do refer to the PDF, which you'll find linked in the description. So thanks for your time.